Question 1. Write the missing number in the space provided. So 56 divided by something equals to 8. Now this is our 8 times table. If we know our 8 times table, we'll know that 8 times 7 makes 56. So therefore 56 divided by 7 makes 8. The answer is 7. No more working out needed here. Question 2, here is a number sequence, write in the missing number. Well, firstly, we want to see, is this sequence increasing or decreasing? Well, this sequence looks like it's increasing because it's going 3, 6, 10, 15. The numbers are going up. And if we look at the difference between each number, between 3 and 6, there's a difference of 3. Between 6 and 10, there's a difference of 4. Between 10 and 15, there's a difference of 5. Next, therefore, we want a difference of 6. So if we add 6 to 15, we get 21. That's our final answer. 3. The diagram below shows a triangle not drawn to scale. Calculate each of the angles marked X and Y. So there are two rules in relation to angles that we need to bear in mind for this question. The first is that the angles on a straight line add up to 180 degrees. And the second is that the angles within a triangle, they also total to 180 degrees. So we'll need to remember both of those rules to work out X and Y. Let's do X first. We can see that X add 63 makes 180. They add up to the straight line angle. So therefore, X must equal to 180 take away 63. Now, if this was 180 take away 60, then X would have been 120. But we're actually taking away 63, which is 3 away. So instead of X being 120, X will be 117 degrees. And don't forget to write the degree sign because that's the unit in this case. Moving on to Y, we are looking at the fact that 88 add 63 add Y equals to 180 degrees again, which means if we do 180, take away the total of 88 and 63, then we should get Y. Now 88 add 63 is 151, so that means Y equals to 180 take away 151. That gives us a value for Y of 29 and degrees on the end as well. Question 4, it says to change 0.72 to a fraction, leaving your answer in its simplest form. So at the moment, we have a decimal 0.72. That as a fraction is 72 hundredths. Now we want to cancel this fraction down to a simpler form, which means that we're dividing the top, the numerator, and the bottom, the denominator, by common factors, numbers that we can divide both of these by. So we can see at first glance that they are both even. For this reason, we can divide top and bottom by 2, and that would give us 36 on the top and 50 on the bottom, but actually, those numbers are still even. So we could, in the first instance, if we wanted to, divide the top and bottom by 4. So if we divide 72 by 4, then we get 18. If we divide 100 by 4, then we get 25. Now, can we simplify these two numbers any further? Well, not really, because other than 1, they don't have any other common factors. If we look at the factors of 18, they are 1, 18, 2, 9, 3, 6. If we look at the factors of 25, they are 1, 25, and of course its square root, which is 5. Now, none of those numbers are in common. We can't simplify this anymore. Therefore, we have now reached the simplest form, which is 18 over 25. Question 5. 3 take away 2 and 5 ninths. Well, 5 ninths is less than a whole. 9 ninths would be a whole. So if we had 2 and then 9 ninths, that would be 3, which we've got on the left. So we're 4 ninths away, because if we add 4 ninths to the 5 ninths we already have, then we've got the whole, which is the next number. So we're only 4 ninths away, and we can just write the answer, therefore, as 4 ninths. If we want to prove this, then we could say that 3 in terms of ninths, since 9 ninths make up 1, this would be 27 ninths. That's an improper fraction. And meanwhile, this would be 2 wholes, which are 18 ninths. Add those 5 ninths, 23 ninths. So you can see that the answer is still 4 ninths. For the second part of question 5, we need to use a rule known as BIDMAS. This tells us what order we should be doing our operations in. Anything in brackets we need to do first. That's followed by indices, which are like to the power something, so square numbers or cube numbers, those kinds of things. Then after that, we deal with division and multiplication. Now that's this second part that we've got here. That is followed by addition and subtraction. So we actually do this part before going on to the +2. So first of all, let's do the 4 times 3/5. Well, 4 is the same as 4/1. This just becomes 12 on the top and 5 on the bottom. When we have 12/5, this is known as an improper fraction where the numerator is bigger than the denominator. So we can turn that into a mixed number and say this is 2 wholes and 2/5. Now, don't forget to add the 2 that we had at the beginning there. So at the moment, we've got 2 and 2/5. If we add 2 to that, then we get 4 and 2/5. My garden centre sells summer bedding plants at 85p each. I have £30 to spend. How many plants can I buy? Show you're working. So we're trying to see how many times does 85p fit into £30. Now, these are two different units. This is in pence and this is in pounds. So why don't we go ahead and convert this into pence as well? That would be 3000p because there are 100 pennies in a pound. So if we've got £30, we need to multiply that by 100 to get the total number of pence. Now that everything's in the same unit, we need to think how many times does 85 go into 3000? So we're doing 3000 divided by 85. For this question, it's literally just asking what's the biggest whole number. In other words, we don't need to worry about any sort of remainder. Since 3000 ends in a 0 and 85 ends in a 5, we know that these are both in the 5 times table. We can divide the top by 5 and get 600. We can divide the bottom by 5 and get 17. Now, it's much easier to do 600 divided by 17 than it would be to do 3000 divided by 85 in the same format. So all we've done is we've simplified the top and the bottom by dividing them both by 5. The proportion here is the same. So whatever whole number we get here on the top, that will give us the whole number of plants that we can buy. Of course, we can ignore the remainder because we just want to know how many plants can we buy. So how many times does 17 go into 6? Well, it doesn't. So technically we'd have a 0 here for the place value. And then how many times does 17 go into 60? Well, 17 times 3 is 51. That's the biggest number that goes in there. We've got a remainder of 9. So how many times does 17 go into 90? We just did earlier that 85 divided by 5 was 17. So 17 times 5 is 85. We do have a remainder of 5, but as I said, we don't need to worry about that as we've divided the initial numbers by 5. So we can buy 35 plants in total. Now, if we actually think about what this remainder 5 means, it's like we've got 5/17 left over. Remember, we were dealing with 85p's. So it's like we've got 5/17 of the 85p left over. Actually, we've got 5 times 5, which is 25p left over. So we've got 35, and I would write plants as the unit just to be safe. Question 7, write in what the 2 missing digits could be. So the first number we've got is something 34. And the second 3-digit number we've got is something 97. It's much easier to do this with column addition because then we can see things visually. Now, we already know that the answer that we are expecting is 631. So we can go ahead and fill that in. Now, if we do this in a column addition style, 4 add 7 is 11. So you've got 1 extra 1. 9 add 1 is 10, add 3 is 13, so that's where this 3 comes from, but we've got the extra 1. Now, 1 add these 2 mystery digits adds up to 6, which means that if we take this 1 off the 6, these 2 mystery digits must therefore add to 5. So there are multiple ways this could work. You could have 1 and 4. You could have 4 and 1. You could have 2 and 3. You could have 3 and 2. So as you can see, there are many combinations, which is why it says what these could be. It doesn't say that there's one specific combination. So just for the sake of this answer, I'm going to put 2 and 3 as it's one of the combinations that works. Question 8. Brian has 7 dominoes in a bag. He takes out 1 domino and finds the total of the 2 numbers. This is because each domino contains 2 numbers, 1 on each side. He then puts the domino back in the bag. His 7 dominoes are shown below, together with a graph of his results after doing this experiment 100 times. So on 100 different tries, he takes a domino out of the bag. Out of these 7 dominoes, he then sees what the total is of the domino. So for example, if we take this 3rd domino, let's say he picks this out, the total would be 6 add 2, which is 8. So what he does is he does this 100 times and he records this in a graph where the frequency, this vertical y-axis that we've got here, this is showing us how many times each total was counted. So the total of 4 came up somewhere between 20 and 25 times. The total of 6 on a domino came up the most, as we can see. A total of 7 never came up though. So the next question asks us, explain why the total of 7 never came up. To answer this, we need to go back to our dominoes and see what the totals actually were of these dominoes, because that's going to give us clues as to which are more likely to occur or which won't occur at all. So looking at the first domino, 1 add 3 is 4 for the total of this domino. 5 add 1 is 6. 6 add 2 is 8. 2 add 4 is 6. 5 add 3 is 8. 2 add 3 is 5. 3 add 3 is 6. So what you'll notice is that the number 7 never appears. If none of the dominoes have a total of 7, then of course he will never get a total of 7 coming out of the bag. So in answer to this question, no domino has a total of 7. As no domino has a total of 7, the total of 7 appears 0 times. It is impossible for him to get this result. So I'm just going to go ahead and write that. Part B then asks us to explain why the total of 6 came up the most often. Well, if we look at the possibilities that we had, our totals, they were 4, 6, 8, 6, 8, 5, 6. There are 7 different possibilities of dominoes that we can get. 3 of those are 6s, so 3/7 chance that we're going to get a total of 6. 2/7 chance we'll get a total of 8, 1/7 chance we'll get a total of 4, and 1/7 chance that we'll get a total of 5. Brian had 3/7 chance of picking 6 as a total. This was the highest of any total. There are more dominoes with 6 spots in total than there are dominoes with any other number of spots. So time to write that down. There's a little bit more that we can say about this topic though, since we're on this question. That is that 6 appears the most. This in maths we call the mode. So the mode is the number that appears the most because it's the most common or the most frequent or the most popular. Those are the 3 keywords that we need to look out for when we're dealing with the mode. 6 is the most common number here, therefore it is the mode. 9a, 93, take away something, take away 18 equals 36. Well, 18 add 36 is 54. So at this stage, we're at 54. So 93 take away something makes 54. Or we can say, what's 93? take away 54. If it was 93 take away 53, then the answer would have been 40. But given the fact that it's 93 take away 54, it's going to be 1 less than 40, so it's going to be 39. With 9b, we've got another BIDMAS question. Remember when we need to do brackets first, followed by indices, then division, multiplication, then addition and subtraction. Ordinarily, if we didn't have these brackets, then we'd be doing multiplication before addition. But given the fact that we've got brackets here, this bit needs to be dealt with together and first, and then we multiply. So something times 7 makes 91. That something is 13. 13 times 7 is 91. Therefore, we need to find 8 add what makes 13? In this case, the answer is 5. Now, in this next question, we're asked which of the following fractions is closest, that should say, to 1/4. So let's see how far off 1/4 each of these are. And then the smallest difference away from 1/4 will tell us that that number is indeed closest to 1/4. In the case of 11 over 40, if we have 40 as the denominator, 1/4 of that would be 10, but we have 11, so we've got 1/40th too much. We are 1/40th away from a quarter. In the next case, 15 out of 60 would be 1/4, but we've got 16 out of 60, which is 1/60th more than what we need. In the next case, 21 out of 80 instead of 20 out of 80, which is what 1/4 would have been, which means we are 1/80th away. Let's look at the fourth one, 26 out of 100, where 25 out of 100 would have been 1/4. In each case, what we're looking for really is for the denominator to be 4 times as big as the numerator. So that's why I'm looking for something close to 25 out of 100, but 26 out of 100 is 1/100th away. Finally, with 31 out of 120, 30 out of 120 would be 1/4, which means we are 1/120th away. Now you'll notice that for all of these, we have 1 as the numerator for these fractions. So the bigger the denominator is, the smaller the overall fraction is. So 1/120th is 3 times as small as 1/40th, and these fractions are getting progressively smaller. So what we can see here is that 31 out of 120 is closest to 1/4 because it's only 1/120th away. Therefore, we can write 31 out of 120 as our final answer. Now let's see what Susan is doing. She is making a necklace of beads using red and yellow beads in the ratio 2:3. She has 56 red beads altogether. We need to work out how many yellow beads she will need. Now with ratios, the order that the words appear in and the order that the numbers appear in is very important because that order needs to be corresponding. So here we're told that she's using red and yellow. So we've got red first, yellow second mentioned here. That means this 2 is referring to the red, which was mentioned first. This yellow is the 3, which means when we have the ratio of 2:3, for every 2 reds, there are 3 yellows. So if we look at it from a ratio standpoint, the ratio of reds to yellows is 2:3. Now, if she has 56 reds now, that means in the R column, we've got 56. How many times bigger than 2 is 56? It's 28 times bigger. So the same thing needs to happen on the right side. We need to multiply this by 28 so that we see how many yellow beads she needs when she's got 56 red. So then we need to do 28 times 3, which we can quickly do over here. 28 times 3. So 8 3s are 24. We've got extra 2. And then 2 3s are 6. Add that 2 is 8, which means she needs 84 beads. Then it says, how many beads will she use altogether? So we know that the total number of beads equals to the total reds plus the total yellows. Therefore, this has to equal to 56 add 84. And that equals to 140. They've already written the units as beads. If they hadn't, then I would advise you to do that just to be safe. Question 12. The three numbers missing from these boxes are all prime numbers. Write in the missing numbers. So we've got three different numbers. They are multiplying to make a total of 385. So these three numbers each need to be a factor of 385. A factor is a number that the main number can be divided by and it leaves no remainder. So if we're seeing what numbers can we divide 385 by, well, we know that any number that ends in a 5 or a 0 is divisible by 5. Given that this ends in a 5, that means one of the factors is already 5. So 5's out of the way. 5 times something makes 385. Well, we can work out what those two numbers need to multiply to by doing 385 divided by 5. 5 does not go into 3. 5 goes 7 times into 38 because 7 times 5 is 35. We've got a remainder of 3 there, and 5 times 7 is 35 again. So we need to find two numbers that multiply to give 77, and 7 and 11 do the job. Before we move on to the next question though, we just need to check that all of these are prime numbers. Now, prime numbers are numbers that only have two factors, 1 and itself, which means there are no other numbers that you can divide that initial number by other than 1 and itself. So with 5, 1 times 5 is 5. There are no other numbers that multiply to make 5. With 7, 1 times 7 is 7. There are no other numbers that multiply to make 7. And when I'm talking about other numbers here, I'm still referring to whole numbers or integers. And then with 11, again, 11 is prime. So that means this question is correct. Brian is looking at the schedule of TV programs for that evening. So we've got two boxes here. One is showing us BBC One and the schedule here, so the programs beginning at different times on BBC One. The other box is ITV. It's telling us which programs are starting and at which specific times on ITV, two different channels. Brian watches the film on ITV, which is over here. But after half an hour, he changes the channel to BBC One. What is showing on BBC One when he changes channel? Well, he started watching the film on ITV. This started at 6:20. Half an hour, in other words, is 30 minutes. So 30 minutes after 6:20, it would be 6:50. This is the time when he switches to BBC One. Well, what's on BBC One at 6:50? At 6:30, Top of the Pops started, as we can see here. That is still going on until 7:10, which means somewhere in here, 6:50. At this point, Top of the Pops is still going on. So what is showing on BBC One when he changes channel? This would be Top of the Pops. Then it tells us that the drama on BBC One lasts for 1 hour and 40 minutes. What time does it end? Well, the drama starts at 9:25, and we need to make sure we're on the right box. This is BBC One and drama 9:25. So it starts at 9:25. We need to add 1 hour and 40 minutes onto that time. If we add 40 minutes, then that takes us to 10:05, because if it was 9:20 and we added 40 minutes, then we'd just reach 10 o'clock, but this is 5 minutes more than that. That's why adding 40 minutes onto 9:25 is going to take us to 5 minutes past 10. But then we also need to add this 1 hour. So instead of 5 minutes past 10, the final answer is going to be 5 minutes past 11, which is 11:05. Question 14, make a list of all the whole numbers which leave a remainder of 7 when divided into 46. So first of all, if we have a remainder of 7, the number itself has to be bigger than 7, because if we're, let's say, dividing by 2, which 46 can be divided by, you just have 23, no remainder. If we divided by something like 3, then you could have a remainder of up to 2. You know, for example, if we divided this by 3, you would have 15 times 3 is 45, remainder of 1. So when we're dividing and we have a remainder of 7, the number that we're dividing 46 by has to be bigger than 7 in the first place. So when we have a remainder of 7, that means that the numbers are multiplying to make 39. So let's think about the factors of 39. You could have 1 times 39 is 39. You could have 3 times 13 is 39. But I already discussed that the number we're dividing by has to be bigger than 7. So 1 is not an option. 3 is not an option. 39 is an option. And 13 is an option. Let's just check these two. So if we do 46 divided by 39, I know this looks big, but don't worry, because 39 goes once into 46, and we've got leftover 7, so remainder 7, which is what we wanted. So tick. Meanwhile, what happens if we divide 46 by 13? Well, 13 threes are 39, and we've got a remainder of 7, so tick. So we've just tried and tested these two. Those are really the only two options. Therefore, your answers are 13 and 39. The charge £C made by a caterer for arranging a birthday party for n people is given by the formula C equals 3n plus 40. This topic is called algebra, which is where we replace an unknown value with a letter. So it firstly asks us, what is the charge in pounds for a party of 20 people? Well, which letter is representing the people? It says n people. So when we have a party with 20 people, that is suggesting that n equals to 20. If we then substitute this value for n back into the equation, we are saying 3 lots of n, where n is 20, so 3 lots of 20. So we're actually rewriting this formula by saying C equals to 3 lots of that 20, and then add 40 from the original equation, which equals to 60, add 40, which is 100. They've already given us the pounds in units. It then goes on to ask us, what is the average cost per person for a party of 20 people? So that means if the total cost for 20 people is £100, what is the cost per person? What happens if you divide 100 between 20 people? So 100 divided by 20 equals to £5 per person. 16, study the graph below. The coordinates of A, B, and C are shown here. Let's start with the coordinate of A. The coordinate of A is 3, 1. That means 3 on the x-axis or the horizontal axis and 1 on the y-axis or the vertical axis. So this is 3, 1. B is 6 along, 2 up, and C is 12 along, 4 up. All of that matches with what they've said here. The value of D, which is not shown, it hasn't been marked, is also somewhere along this line. It also lies on this line. If D is 15 for the x coordinate, then what is the value of this little a, where a is the y coordinate of this capital D point that we're looking for? Well, we need to find a relationship between the x and the y coordinate in each case. I mentioned that the x coordinate comes before the y coordinate. So here the x coordinate is 3, the y coordinate is 1. We went from the x to the y coordinate by dividing by 3. What happens here? 6 divided by 3 is also 2. So you've guessed it, 12 divided by 3 is also 4. So if we start off with 15 as our x coordinate, and we want to work out what this y coordinate should be, if this new point is also somewhere on the line, that means we need to do 15 divided by 3, which gives a y coordinate of 5. So in theory, this would be 15 on the x-axis, which is off the scale somewhere here, and then 5 on the y-axis, which is off the scale somewhere there, and it would still be an extension of the existing line. Next, it says that E is another point which is not shown, and for E, we have the coordinates B, 8. So B is our x coordinate, and 8 is our y coordinate. Well, we know that we need to divide by 3 this way to get from our x to our y. So if 8 is our y coordinate, then B must be 3 times as big as 8, which means that B is 8 times 3, which is 24. In other words, when we have coordinates in this case, like x and then y, then here we can say that x equals to 3y, because whatever the y is, the x coordinate here is going to be 3 times as big. This will help us to answer the next question. In the next question, it says if P, Q is another point on the same line, write down a relationship or equation between P and Q. Now, in this case, they haven't given us any numbers. They haven't given us a value for the x coordinate or a value for the y coordinate where we can multiply or divide by 3 to get a numerical value. So what we need to do is treat this just as we did over here. Here we said, if this is the x coordinate, if this is the y coordinate, then x equals 3y. Well, all we're doing here is replacing the x with P and replacing the y with Q. So if we just copy what we did above here, we can say P equals 3Q, and that's our answer. Make sure you write the Q clearly. You don't need a massive flick, but make sure it doesn't look the same as the number 9, because then that's going to look confusing. Just something to be careful about. 17A looks like column addition, so we've got 68.9, add 9.86. Just remember the place value here. So 0 add 6 is 6, 9 add 8 is 17, so we've got 7 extra 1. 9 add 1 is 10, add the 8 is 18, so 8 extra 1, 6 add 1 is 7, so we've got 78.76. Next, 321, take away 268. Well, 1 take away 8 we can't do, so this is 1, we borrow 1 from there. 11 take away 8 is 3. 1 take away 6 we can't do, so 2, 1, 5, and nothing there because 2 take away 2 is 0. So this is just 53. Of course, you can do these in your head if you want to, but if these questions are, let's say, 2 marks, then you would get 1 mark for the working out, which is why I'm just doing this in case it's worth showing it. 391 times 7. So 1 times 7 is 7. 9 times 7 is 63. So that's 3 and 6 that we're carrying over. 3 times 7 is 21. Add that 6 is 27. So 2737. Last part of question 17, we've got 656 divided by 8. So 8 times what is almost 65, or 8 times 8 is 64, remainder 1, 8 times 2 is 16, so 82 would be our answer. Brian starts with 1000 and subtracts 11 each time. The first 4 numbers in his sequence are 1000, 989, 978, 967. So this is a sequence which has decreasing numbers in the sequence. We're taking away 11 every time. If he continues in this way, what will be the first negative number in his sequence? Now, if 1000 was in the 11 times table, and we kept taking away 11, take away 11, take away 11, take away 11, eventually we would hit exactly 0. But given the fact that 1000 is not in the 11 times table, we're not going to hit exactly 0. So let's see how far off the 11 times table we actually are in this sequence. We can take any of these numbers. So let's just take 989 as an example. If we do 989 divided by 11, how many times does 11 go into 98? Well, the closest is 88 because 99 would be too big in this case. So 11 times 8 is 88. We've got a remainder of 10. Then how many times does 11 go here? Well, 11 times 10 would be 110, but that's not working. So it's 89. And 11 times 9 makes 99. Again, we've got a remainder of 10, which means that the last positive number that we're going to get is going to be 10. We are 10 ahead of 0. We are 10 ahead of the 11 times table. So if the last positive number that we have, if we keep taking away 11, is 10, well, if we start with 10 and then we take away another 11 to cross that line and go into the negative numbers, that equals to -1. So -1 will therefore be the first negative number in the sequence. On to question 19, find the missing numbers so that the answer is always 56. So we've just got different types of operations here. So 17 add what makes 56? Well, if it was 17 add 40, it would be 57, but we're one less than that. So we also need one less than 40, which is 39. 131 take away what makes 56? We can do this in our heads if we want to and get an answer of 75, or alternatively, you could do it with column subtraction and you could think, what is 131 take away 56? And then you could do it this way. So 1 take away 6 you can't do. 3 becomes 2, this becomes 11, take away 6 is 5, and then you've got this 12 take away 5, which is 7. 50% of something is 56. Now we need to be careful not to do 50% of 56 because that's saying half of 56. But actually what's happening here is it's saying 50%, so half of a number is 56. 56 is only worth half of the total. That means we need to double 56, giving us a total of 112. So 50% or half of 112 is 56. Then 560 divided by something is 56. So 560 has a 0 on the end, which is referring to a factor of 10. If we divide 560 by 10, so we take this 0 off the number, we are indeed left with 56. That means we can divide 560 by 10 and we can get our 56 as required. Then here it says 1/3 of something is 56. That means we need to do 56 times 3, just like here we did the reverse. So 56 times 3, well, 50 times 3 is 150. 6 times 3 is 18. Add the two together is 168. Alternatively, of course, you could do 56 times 3 like this. So 6 times 3 is 18. You've got 8 extra 1. 5 times 3 is 15. Add that 1 is 16, gives you the same answer. Final question for today. 2 rectangles A, B, C, D and P, Q, R, S are shown below. That means we can call this point C. Calculate the shaded area. Now, hopefully we can see that this shaded area is the same as this big rectangle, the ABCD rectangle. Take away part of this rectangle. We don't need all of this rectangle. We just need to take off this portion of it. So what we need to do is work out these dimensions, then we can find out the area of this small rectangle, take that away from the big rectangle ABCD, and we're left with all of this shaded stuff. So first of all, here we're told that AD is 3 centimeters, so we can write 3, annotating over here is helpful. AB is 5. Now AB is parallel and the same length as CD over here. So if AB is 5, well, this line at the bottom of the rectangle is also 5. That tells us that the big rectangle area would have been 5 times 3, which is 15. PQ, we are told, is 2 centimeters, so this is 2. PS is 2 centimeters, which means QR is also 2 centimeters. And within QR, which is 2 centimeters, BR is 1 centimeter. It's not to scale, remember, so this is 1, and this is also 1. Now that gives us the answer as to what this little rectangle area should be, because we've got the dimensions of 1 and 2. So small rectangle area equals to 1 times 2, which is 2. So I said at the very beginning that to find this shaded area, we need to do the big rectangle area, take away the little rectangle area. In other words, we need to do 15, take away 2, which equals to 13. Therefore, the answer is 13. And that's it for today's paper. So if there are any other papers that you would like me to cover from any other schools, please let me know in the comments down below, and I will see you next time.